this mini lecture will cover a bit more information about stars that you might find useful, the naming and brightness scale. Kepler, Galileo, and Newton are among the first true scientists and founders of the scientific method. These science rock stars use observations and data to discover the principles behind their motion of the planets and how the solar system is ordered. Today I'd like you to become familiar with the naming system and brightness scale for the stars. It will be very helpful for you as you do your research and prepare your Constellation of the Week field guide page each week. Last week we learned about how ancient cultures celebrated heroes, gods, and mythical beasts by giving their names to groups of stars and constellations. Most of the constellations visible from the northern hemisphere have myths associated with them, while the southern constellations are more recently named and often named after objects like microscopes or Columbia, the dove. As you research your constellation, don't be surprised that the star patterns do not look like the creatures they're named for. Does Columbus, Ohio look like Christopher Columbus? They're just suggestions. The names of some of the stars and constellations you see in the sky may be among some of the oldest surviving traces of human culture. In antiquity, constellation boundaries were poorly defined and shown on a map with curving dotted lines. Stars were not even included in the constellations. But in 1928, the International Astronomical Union, IAU, established 88 official constellations with clearly defined boundaries that include every part of the sky, north and south. It's important to note that a constellation is more than just a group of stars. It's an area in a sky, and any star within that region belongs to one and only one constellation. This region of sky with precise boundaries is analogous to the political boundaries found on a map. In addition to 88 official constellations, the sky contains many recognizable groups of stars that are not constellations. For example, the Big Dipper you'll learn about in Week 3 lab is a very well-known asterism near the North Pole star Polaris, and it's part of the constellation and located within the constellation Ursa Major, the Great Bear. But the Big Dipper itself is not a constellation, it's an asterism. The Pleiades is another group of stars you can recognize, not a constellation. So there's many of these. Remember, the official definition of a constellation is it is a specific area of the celestial sphere with boundaries laid down by the International Astronomical Union, and it has a recognizable group of stars within it. But now it's time to go over how stars are named. Ancient astronomers gave individual names to the brightest stars. Modern astronomers still use those official ancient names. For example, Betelgeuse is a bright orange star in Orion, and it comes from the Arabic Yad al-Jawza, the hand of Jawza, who was the giant. We call the giant Orion today. Today there's an official naming system for stars, and it really is better than having thousands of individual names to memorize. So there's a system. And the system is that the stars are named after their constellation, usually in Greek, in order of brightness according to the Greek alphabet. So the brightest stars are Alpha. The brightest star in Orion would be Alpha Orionis, otherwise known as Betelgeuse. And then there's Beta Orionis, the second brightest, known as Rigel. Describe the brightness of stars also with another scale. So if you want to see how bright a star is. So the number is used in the visual magnitude scale. It's a number usually from 1 to 6, but not completely from 1 to 6. So ancient astronomers logically assigned the brightest stars to be the first order magnitude. They're the brightest, they're first. And then the faintest stars would go down, second, third, fourth, and then to the very faintest down to sixth order was the faintest you could see with the human eye. And it would often be used for an eye test if you could see them or not. But we have electronic digital instruments to precisely measure the brightness of stars, so we can give them numbers like 2.34. Let's look at an example. The star known by the charming name, the ancient name of Chort, was later classified as Theta Leonis. It's the 8th brightest star in the constellation of Leo. Now this is a third magnitude star, so it's not as bright as a first or second, it's a third order. Some of the brightest stars in the sky, known as first order, would be Sirius and Rigel. But short is more precisely classified today, if you look it up, as 3.34. Some stars are actually brighter than magnitude 1. So brighter than the first order, how can that be? Well, Sirius, even though it's a first order star, it actually has a magnitude of negative 1.47. On the far end of the scale, astronomers use numbers greater than 6 to define faint stars only visible by telescope. So I want you to remember that we're classifying stars by the way they appear to us in the night sky. It doesn't tell us the actual luminosity or intensity of the star. So you could have a super, super bright, powerful star that's very, very far away, and it's going to look faint, just the same way a car headlamp miles away will be much fainter than a little dim flashlight that's poking into your eyes. Classified by their magnitude, and you learned a little bit how stars are named within their constellation. Enjoy researching your constellation this week and making your first official Constellation of the Week page, cow page, for your very own field guide to the night sky.